this is Miss Soma. So today I'm going to be talking about how you compare numbers written in scientific notation, percent, and decimal. But before watching this video, I would encourage you to watch my video on writing numbers in scientific notation first, so that you will understand why we're doing such things on changing numbers into scientific notation. All right, so let me have four numbers here. So a number written in scientific notation, for example, is 2.6 times 10 to negative 1. And then let's have a number written in percent. Let's say 7%. And then a number written in decimal. Let's do negative 2.6. And let's have a number also written in fraction. So I also would like you to look at my video on long division, so that should show you how to do long division. Although in the case of my 7th grade extended students, since you will be allowed to use calculator all throughout your SOL test, so you really don't have to learn long division, but just for additional review, you may watch that video. So let's have 8/9. Okay, so what I'd like my students to do, or whichever is easier for you, is to convert all of these numbers in the same notation. So my favorite thing is to change them all into decimals. Or if you like, change them all into percent. It's up to your comfort level, but it has to be all in the same notation. So then it becomes easier to compare them. So I'm going to change my 2.6 times 10 to negative 1 in terms of decimal notation. So now this becomes, so it's negative 1. So I'm going to move one step to the left. So it becomes 0.26. And then my 7%, anything that is percent is out of 100. So 7 divided by 100. So it's 7 hundredths. That would give you 0.07 or 7 hundredths. And then this is already in decimal form. So it's negative 2.6. And 8/9, if you remember what we did with anything divided by 9, that becomes repeating. So this is just 0.8 repeating. Okay, so now they're all in decimal form. So now we're ready to compare. So what I like doing is line up all their decimal point. So 0.26, 0.07, negative 2.6, 0.8 repeating. And then I'd like to make their number of digits even. So this is 60. And then the 8, since it's repeating, it's going to be followed by 8. All right. Okay, so now which number is less? So you would be saying vocabulary words such as ascending. So arrange in ascending order. Ascending is going up, so that means least to greatest. Now the opposite of it is descending. That means going down. That means greatest to least. Okay, so for the sake of our example, let's just do ascending. To be honest, I'd like, even if the direction is descending, I still want you to do it in ascending order and then just reverse it. Because it's easier, it seems easier for our brain to look at numbers from least to greatest instead of going greatest to least. Okay, so let's do ascending order. So since we have a negative number here, automatically that is our smallest. So then our smallest is negative 2.60, followed by, okay, 26. So all of them are all zeros. So let's look at here, 26, 7, and 88. So 2, 0, or 8. So 0. So 0 0.07, followed by 2 or 8. So 2. Then 0 0.8 repeating. Then make sure that you write their original, the given notation. So that's negative 2.6, followed by 0 0.07, 7%, followed by 0 0.26, which is 2.6 times 10 to the negative 1, followed by 8 over 9. And this is your answer. Okay, let's try another one. I want to put several negative numbers. So I'm going to put 3.4 times 10 to the negative 2, followed by negative 180%, followed by negative 7, followed by, let's do 6 over 7. So we can do long division. Okay, so I'm going to change them all into decimal. Okay, so 3.4 times 10 to the negative 2. So I would have to move 2 steps to the left. So now it's 0.034. My 180, negative 180%. So anything in percent is out of 100. So 180 divided by 100 is negative 1.8. Yes. Then followed by negative 7, and then 6 over 7. So let's do a long division real quick. So 6 divided by 7. And I like making a list of my divisor, which is 7. So 7, 14, 21, 28, 35, 42, 49, 56, 63. Okay? So now there's no set of 7 from 6. So now it's just 0. Now let's add another 0 here. So which number can I use from my list? I can use 63. So now that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. Oh, sorry, I cannot use 63. I can use only 56. So now that's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. So now that's 56. Now subtract. 10 minus 6 is 4. Now add another 0. Okay, so which one can I use? I can use 35. So that's 1, 2, 3, 4, 5. And that's 35. And I like you to stop up to the third digit. Let's go up to thousands place all the time. And then this is 5. Give another 0. 50. So now I can use 49. And that's 7. So this is going to be a repeating pattern. But let's just stop up to 0.857. All right, there's more, and then it should repeat. Okay, so now we have these numbers here. So let's do a descending order. Descending order. So that means we're gonna be doing greatest to least. But my brain is kind of like working well if I'm looking at it from least to greatest, because that's what I was used to. So I'm gonna just do least to greatest first. So I'm gonna focus on my 2 negatives because I know that they are my least. So negative 7 is least, followed by negative 1.8. So I'm done with that. Now let's look at, done with this. Now a 0.857 and a 0.034. So 0, 0.034 followed by 0.857. Okay. Okay. Now we have to write it in their given notation. So the -7 was given as -7. The -1.8 was given as -180%. And then 0.034 was given as 3.4 times 10 to -2. And then 0.857 was given as 6/7. And since my direction is to arrange it from in a descending order, so now all I need to do is just reverse it. So now I'm going to write 6/7 followed by 3.4 times 10 to the -2 followed by -180% followed by -7, and then you're done with your job. All right, till next time. Bye-bye.